Lesson 7-5, Division Properties of Exponents. All right, in this lesson we're going to talk about properties of exponents when division is occurring. Alrighty, here we go. So just like multiplication, when we are multiplying two powers that have exponents and they have the same base, we talked about how we can just add those exponents. So 3 plus 2, we get 4 to the 5th power. Well, with division, it's kind of the same thing, but we do the opposite of adding, we subtract. So in this example, they have 4 to the 5th divided by 4 to the 3rd. We know exponents are repeated multiplication, so 5 4s on the numerator, 3 4s on the denominator. 3 4s are in common, so they cancel out. You're left with 2 4s, or 4 to the 2nd power. We can do this by simply subtracting those exponents. So this is the property we're learning. To divide powers with the same base, that's very important, just subtract the exponents. So if you had a to the m divided by a to the n, they have the same base of a, we can just do a to the m minus n power. So 2 to the 6th divided by 2 to the 2nd, 6 minus 2, we get 2 to the 4th. Let's practice one of those. Alright, here I have x to the 8th divided by x to the 3rd. Notice I have the same base, which is x, so I'm just going to subtract 8 minus 3. I get x to the 5th power. Same thing in b, m to the 2nd divided by m to the 5th. Well, 2 minus 5 is m to the negative 3rd power. And n to the 4th divided by n to the 3rd, I do 4 minus 3. And I get n to the 1st power. Now, we learned that to have an answer in complete simplified form, we want to get rid of negative exponents. So I'm going to put that m to the 3rd on the bottom. Moving it to the denominator makes the exponent positive. And my n to the 1st power can stay. So n over m to the 3rd would be my final answer. All right, I'm going to do one more example. Let's look at E. I'm going to look at each variable or power or base separately. So first looking at the x's. X to the 4th over x to the 4th. 4 minus 4 is 0, and we know that anything to the 0 power equals 1. Y to the negative 1 divided by y to the negative 5th. Well, negative 1 minus negative 5. I'm going to add those. Negative 1 plus 5 is y to the 4th power. And z to the 8th over z to the 1st power is z to the 7th. So it looks like my final answer will just be y to the 4th, z to the 7th power. Alright, you can use the property of dividing powers with the same base to divide numbers in scientific notation. Numbers in scientific notation have the same base because they both have 10 to the something power. Alright, so population density describes the number of people per unit area. During 1 year, the population of Angola was 1.21 times 10 to the 7th. The area was 4.81 times 10 to the 5th miles squared. So what's the population density? We need to take the population divided by the area. That will give us our population density. So population was this number right here, 1.21 times 10 to the 7th power, and I'm dividing that by the area of Angola, 4.81, oops, that's an 8, times 10 to the 5th power. My powers of 10 have the same base here, so I'm just going to take 7 minus 5, and I get 10 to the 2nd power. Then I can just divide this part, 1.21 divided by 4.81, and I'm going to get 0.252 times 10 to the 2nd power. This isn't quite in scientific notation yet, but I'm going to write it in standard notation anyway, so I'm just going to move this 10 to the 2 means I'm moving 2 spots to the right. So 25.2 people per square mile would be the standard deviation. Or sorry, population density. All right, gonna skip that one. All right, you can use repeated multiplication to simplify a quotient raised to a power. So when we had a product to a power, like 4x raised to the second, this power of 2, or this exponent, was applied to the 4 and to the x. Same thing in a quotient, something being divided. If it's raised to a power, that n is applied to the top and to the bottom. So let me show you with an example. All right. What is the simplified form of z to the 4th over 5, and all of that is raised to the 3rd power? So my 3 is going to be applied to everything on top and everything on bottom. So z to the 4th to the 3rd. Well, that's a power to a power, so I'm going to just multiply the 4 times 3. So I actually have z to the 12th. And then on bottom, I have 5 to the 3rd power. Well, 5 to the 3rd power is 125. So that's my final answer, z to the 12th power over 125. All right. So this is another rule, and I'm going to walk you through why this rule works. Let's say we had a quotient, a divided by b, something being divided, but it's raised to a negative exponent. All right, so here we are, a over b to the negative n. We know anything to a negative exponent, if we move it to the bottom, that exponent becomes positive. Okay? So now we also know that a quotient raised to a power, that power is applied to the top and to the bottom. So I have a to the n over b to the n. Now, with fractions, if you have a fraction and you, if you have, I gotta move this screen over. If you have a fraction and it's being divided by another fraction, you can multiply the reciprocal of that fraction. The reciprocal is the numerator and denominator flipped. So a over n times b over n. 1 divided by that quotient is the same thing as 1 times the reciprocal. Notice they flipped the numerator and denominator. Now it's b to the n power over a to the n power. Well, b to the n power over a to the n power is pretty much the same thing as b over a raised to the exponent of n. What they're saying is, so if you have a fraction or a quotient raised to a negative exponent, you can skip all this and just go right to the final answer. This equals the reciprocal of that quotient raised to the positive exponent. Let me show you an example. So I have 2x to the 6th over y to the 4th raised to the negative 3rd power. Okay, so right here. They're saying that I can rewrite this with a positive exponent of 3 by just doing the reciprocal of this quotient. So instead I'm going to have y to the 4th on top and 2x to the 6th power on bottom. That's all raised to the 3rd power, okay? Now, a quotient raised to a power, that power applies to the top and bottom. So I have y to the 4th to the 3rd over 2x to the 6th to the 3rd. So let's see what this is going to look like. Power to a power, I just multiply. I have y to the 12th over 2 to the 3rd, because this applies to the 2 and it applies to the x to the 6th. So 2 to the 3rd is 8. And x to the 6th power to the 3rd, power to a power, I multiply. So 6 times 3 is 18. My answer is y to the 12th power over 8 times x to the 18th power. All right, those are the 4 examples in this lesson. Please do the lesson check 1 through 5 and bring your answers to class.